Hello everybody, we're in section 3.1, and what I'm going to focus on in this video is how to find the domain of a function, because I know this gives students tons of trouble. So for right now, restrictions to the domain, we've only got two of them that we got to worry about. No dividing by zero, and no negatives and even roots. Remember, odd roots are okay. So here, a quick example, like we can have the cubed root of minus 27, that's minus 3, since, well, minus 3 times minus 3 times minus 3 is minus 27. You can get negatives. You can't have them in even roots. For instance, the square root of minus 16 is not a real number. It's not 4, and it's not minus 4. But both of those times itself gives you back 16. Those even roots, you can't get negatives inside of it without imaginary numbers, which right now are real valued anyway. So let's take a look at an example. Okay, here's our first example. Find the domain of the function. So here I'm using the function notation f of x. Remember, it doesn't mean multiplication, means you have a function with respect to x equals 7x to the fifth minus 13x to the fourth minus 3x squared plus x minus 1,000. Okay, remember, you just have to check for those two things. So first, there's no division sign. So dividing by 0 is not going to happen. There's also no roots. This domain would be all real numbers. Everything goes here. Because there's no division, no roots means no problems for now. Alright, let's take a look at a more interesting problem. Okay, let's find the domain of this function. So now I've got g of x, so I just have some new function here equals 17x over x squared minus 4. So we have a classic like good news, bad news situation. The good news, number one, no roots. That's good, but we do have division. So could the bottom turn into 0? And the answer is yes. So it's the only thing we have to worry about are what values make the bottom equal to 0. Those are the things that I need to make sure and rule out. So all I need to do is I take the bottom and I set it equal to 0. It doesn't matter what the top is. You can have 0 divided by a number all day. You just can't divide by 0. Factor this quadratic and solve it that way. So here I get x is minus 2 and x is 2. And those are the values that need to be excluded from my domain. So the domain is a collection of x's such that x is not equal to minus 2 and 2. Those are the values that cause division by 0, and we cannot divide by 0. Alright, let's take a look at a root. Okay, so let's take a what's the domain of this function? So I have some function h of x equals the square root of 7 minus x. So again, the good news is no division. So I'm not worried dividing by 0, but we have square roots. So we have square root. So this inside, what do I need the inside to be? This inside cannot be negative. So what I'm going to do is I'm going to take the inside, make it non-negative, so greater than or equal to 0, and I'm going to solve this inequality. Alright, so let's give this a shot. Move the 7 over, minus 7 minus x is greater than or equal to minus 7. At both sides by minus 1. Here we're going to flip. X is less than or equal to 7. Here's our number line. 7 I've closed in, and I want x values less than that. So I put it all together. The domain of this function would be minus infinity up to 7 bracket. That will produce this being positive, we can take or 0, and we can take the square root of 0 or positive. Alright, let's try to put this all together. Okay, let's find the domain of this function. I have f of x equals 7 divided by the square root of x minus 3. So here I have both things. Alright, I think I can get this down in one shot. So I know I need the inside here to be non-negative, but no dividing by 0 as well. So I'm going to kill two birds with one stone. And I'm going to take the inside. Usually I set this greater than or equal to 0, but here I'm just going to solve this. So it should make sense to you that I'm going to rule out having to be equal to 0. So if I let this inside be equal to 0, then the square root of 0 is 0, and I would be dividing by 0. So move this over, and I get x is greater than 3, number line, here's 3, it's open, I want stuff to the right, and the domain of this function would be 3 to infinity. That's taking care of both of the division and the root part. Alright, and that's finding domains of functions.